Yes, Manish, shall we start?
हो सर, स्टार्ट करा सर.
46 स्टुडंट्स आले.
सर येतील दोन दोन तीन मिनिटात जॉईन होऊन जातील. तुम्ही स्टार्ट करून घ्या, म्हणजे मागची रिव्हिजन स्टार्ट केली तर होऊन जाईल.
ठीक आहे,
तोपर्यंत
ठीक
होऊन
आहे,
जाईल.
ठीक. Okay, okay. So good morning to everyone. I think in the last session, in my last class, I have completed till the interrupts, the types of interrupts. Okay, I have told you there are two types of interrupts. We have hardware interrupt and software interrupt. Okay. In the hardware, it is externally derived from a hardware. Okay, or you can say it is a peripheral device. And software interrupts are which are internally executed, means with the interrupts which we can write down in the instruction itself. Okay. And we have also studied about the maskable and non-maskable. Okay. Mostly the pins which are associated with the hardware, they are INTR, NMI, INTA. Okay. And there is a request and acknowledgement. Okay, so three are there. And I have told you the difference between the maskable and non-maskable. Then we have seen there are total 256 interrupts, software interrupts, that is INT00 to INTFF. So it becomes total 256 interrupts. Okay. Now in the software interrupt, I have told you that this actually what is happening. Okay, I have given you the steps. I hope you have understood this, because I have explained you very much into the detail of the what are the steps happening. Okay, what is moving into the stack, पहले क्या जा रहा है, बाद में क्या जा रहा है. Okay, then I have told you that return address has to be present into the IP instruction pointer. Okay, so whenever there is a software interrupt, you are going from the main program to the ISR, that is interrupt service routine. Okay, it is specifically you are moving from main program to the subroutine program. That is why it is called as interrupt service routine. And while transforming from the main program to the ISR, what actually is happening? आप डायरेक्टली जंप नहीं करते हो मेन प्रोग्राम से आईएसआर में, उसके पहले हमें कुछ करना पड़ता है. सो वी हैव टू रिस्टोर द फ्लैग्स, we have to restore the CS value, we have to restore the IP. Okay, so CS is loaded. I of in the as far as the flags register are concerned, we are mostly dealing with the two bits, that is IF and TF, that is interrupt flag and trap flag. Already I have explained you about the interrupt flag. Okay, the trap flag I need to explain you. I will explain you this thing when I will be talking about the interrupts, the registers I am talking about. Okay, so we have written the 5 steps which are happening. Okay, so the first step was the flag register value is pushed onto the stack. Second, ऐसा होता है कि CS value of the return address and IP value of the return address are pushed to the stack. Okay, रिटर्न वैल्यू, क्योंकि मुझे ISR से वापस रिटर्न होना है, तो रिटर्न का जो एड्रेस होता है वो मुझे पुश करना पड़ता है स्टैक में. Then the third is the IP is loaded from the content of the word location. That is the type number. And I have told you the type number into 4. The type number into 4. Okay. Always remember the type number into 4. And that is IP is loaded from the content of the word location. Okay. क्योंकि IP में जो वो कंटेंट जाएगा तभी प्रोसेसर को पता चलेगा कि प्रोग्राम the program pointer has to jump from main program to the particular address in the ISR, particular address in the ISR. Okay, लेकिन that particular address is in which particular segment, that is given by, that information is given by the CS. So that's why the fourth step is CS is loaded from the content of the next word location. So please remember the first word location and the next word location. First word location gives you the IP, and the next word location will give you the CS. IP will give you the exact address, and the next word location will give you the which segment. Or in simple word, you can say CS will store the base address and IP will store the offset address. Okay, that is as simple as it is. And the fifth one is IF and TF are reset to 0. क्योंकि interrupt आने के कारण you can see the changes happening in the IF and TF. तो वो changes को reset करने को we have to reset. So automatically your IF and TF will be reset. ये सब होने के बाद you will jump to the ISR. ये सब होने के बाद you will jump to the ISR. You will execute the small program in the ISR. Okay. I have told you that is a vector address, and vector address कौन बताता है? Your type number, and that type number has to be multiplied by 4. Okay. Even I have told you that your 1K, because you know that you have a memory address location. Okay. And the initial and every your segment every segment, that is 4 segments, is of 64K. But initial 1K value, initial 1K memory space is reserved to contain the vector address. Okay. So every 2 locations, first word, second word, every 2 locations out of the 1K is reserved for 256 interrupt types. 256 interrupt types. Okay. So I hope everything is clear, because whatever I am explaining you have to imagine. Unless and until you imagine, you have to form the picture in front of your eyes. Then only you will be able to understand this concept. This is not the concept which you have to memorize. This is not the concept which you have to mug up. It has to be visualized. It has to be imagined. Then only you will be able to write down you will be able to write down the answer in the paper, and you will be able to understand. Okay. So please imagine your main program, your ISR, your 1K of memory space reserved for the vector addresses. How to calculate the vector address? So everything you have to imagine. Everything I have explained in my last lecture. As there was a huge gap, I am just revising. I'm just revising. Okay. So your INT NN, मैंने बोला था small NN. So small NN gives you the type of the interrupt. I am specific to my software interrupt. So NN stands for software interrupt, that is 00 से लेके FF in hexadecimal. Okay. So यहाँ तक हमने किया था. I have told you there are few interrupts which you have to understand. Okay. Question कभी कभी पूछा जाता है. So there are mostly 5 interrupts which you have to just understand. Okay. And these are the starting 5 interrupts, that is INT0, INT1, INT2, INT3, and INT4. Okay. So you can just write down some sentences on this, then we'll proceed further. Today I will be doing the directives. Okay, assembler directives. Are you able to see on my screen assembler directives? Manish, this guy? Okay. So I will just start the slideshow. But before I go to the assembler directives, we need to complete this interrupt 0 से लेके 4 तक. Okay. So there are many interrupts. आप जब देखोगे ना, I'm just giving you about the only 5 interrupts. But if you are interested to understand the other interrupts, you can just go through, because sometimes the question in the Viva can be asked. But as far as the theory exam is concerned, only starting 5 interrupts are more important. So please write down INT NN interrupt. सिर्फ heading लिखो INT small NN interrupt. INT I capital, N capital, T capital, space. Are you able to correlate? Are you able to link? Okay, whatever I explained. क्योंकि ऐसा नहीं होना चाहिए कि I am explaining और वो सब ऊपर से जा रहा है. Because already I have taken this in my last class. Okay.
Yes,
so
sir,
whatever doubt you have, please ask me. थोड़ा क्यों? अभी ज्यादा आपको गैप मिला था ना, पढ़ाई नहीं, आपने रिवाइज नहीं किया. अभी थोड़ा नहीं बोलना चाहिए ना. मैंने अभी कुछ नया नहीं बताया. मैंने ये जो ऑलरेडी सिखाया वही मैंने रिवाइज किया है. मैंने कुछ नया नहीं बताया. देयर यू शुड नॉट टेल मी कि थोड़ा समझे. हाँ, आपने अगर रिवाइज नहीं किया तो आपने सॉरी बोलना चाहिए. अगर रिवाइज किया तो यू शुड नॉट से सॉरी. यू शुड बी थरो टू दिस, because already I have explained you this, and in that also in very much detail.
Sorry, sir.
With my understanding, if you read, revise नहीं किया मतलब okay, please revise that. So with my teaching, you please correlate with the ebook I have shared, the ebooks which I have shared to you. That is author of Nagur Kani. So in that you please correlate and try to understand. And if you do not understand, you please ask me. Okay. So what you have written, int and an interrupt, write down below that. It runs the ISR pointed by, it runs the ISR, bracket में लिखना तो लिखो, interrupt service routine, bracket close. It runs the ISR pointed by vector nn. Vector nn को underline करो, that is important. Run the ISR pointed by vector nn, small n. Okay. So write down number one interrupt, that is write down point number one, int 00h. Now this is the first interrupt. Amongst the total 256 interrupts, starting from int 00 to int 255, okay, this is the first interrupt, software interrupt, that is int 00h. So what is int 00h? उसके सामने लिखो int 00h, उसके सामने लिखो, this is reserved for divide by zero error. It is reserved for divide by zero error. It is reserved for divide by zero error. Now I want everyone to pay attention now. What is this int 00? What is this int 0? H. Now whenever during some operations, by mistake, if it happens that there is divide by zero, and you know divide by zero is, yes, anyone? What is divide by zero?
So not defined.
It is not defined. It is not defined. So whenever by mistake or unintentionally if it happens that there is some operation which is divided by zero, okay, there will come a message, will pop up that there is a int 00h, or there is an error, or there is divide by zero error. Mostly the message comes to be it is a divide by zero error. So ये message क्यों आता है? Because there is some operation happening intentionally or unintentionally in which there is divide by zero. तो ये message जो pop up होता है, that message क्यों आता है? Only because of this error, that is int 00, that pointer will go to the ISR pointed by vector 00h, और वो vector 00h में जो भी कुछ small program लिखा है, that is your ISR, वो ISR में जो छोटा program लिखा है, वो program यही लिखा है कि वो program जब execute होता है तो वो program will give you that message that there is a divide by zero error. So can I say that small program is written to make that what is the main purpose of that small program? To give you the message divide by zero error. To give you the message divide by zero error. वो divide by zero error यही small program के कारण आपके screen पे देखने को मिलता है. So can I say this is a software interrupt? Okay, this is a software interrupt. So this software interrupt will give you the particular message, okay, and this message, that is a divide by zero error, will pop up on your screen, and this is only because of that ISR. That is only because of the ISR. That is interrupt service routine. Okay, interrupt service routine. So हमेशा याद रखना कि जब भी मैसेज कुछ आता है तो that means somewhere in your program there is a process happening in which there is divide by zero. There is divide by zero. That is the meaning. Okay, that is the meaning of this. So software interrupt आप प्रोग्राम में लिखो int 00h लिखो. Mostly means 100% we do not write int 00, but this is software. This is software generated. This is because of some processing happening at the background. This is because of some processing happening at the background, and during that processing, if the processor founds or encounters this divide by zero, then the message will pop up, that is divide by zero error. Divide by zero error. इसका मतलब वो प्रोसेसर को अगर वो कुछ डिवाइड बाय जीरो का प्रोसेसिंग कुछ भी मिला, in that case it will move from the main program, it will go to the ISR pointed by the vector 00, and वो ISR में ऐसा छोटा सा प्रोग्राम लिखा है जिसके कारण आपको वो मैसेज मिलता है, जिसके कारण वो आपको मैसेज मिलता है, there is a error divided by 0 or there is divided by 0 error. So whatsoever. Okay. So you can say there is int 00 interrupt has been executed. int 00 h software interrupt has been executed. Okay. So this is int 0. Write down the second one, int 01h. int 01h. int 01h. Write down, it is reserved for single step operation. This is reserved for single step operation. तो मैंने जैसे बताया था, इफ यू प्रेस, आप टैजम में जब करते हो, अगर 1 by 1 इंस्ट्रक्शन को एग्जीक्यूट करना है, ओके, 1 by 1 अगर इंस्ट्रक्शन को एग्जीक्यूट करना है, सो यू आर प्रेसिंग व्हाट, F9 और F8?
सर F8
हाँ, F8, हाँ, yes, F8 is for to execute 1 by 1, ताकि हमको समझ में आता है कि ये इंस्ट्रक्शन एग्जीक्यूट होने के कारण क्या हुआ, ये इंस्ट्रक्शन एग्जीक्यूट होने के कारण क्या हुआ, और आपको पता है वो व्हाइट में दिखता है, it is highlighted in the white color. Okay, so you will able to understand what registers are updated, what flags are updated. Okay, so everything you are going to, you will be able to see by step execution. So whenever you have to execute single step operation, okay, you can use this int 01h. Okay, या फिर now all of you pay attention, this is important. या फिर can I say, whenever I am pressing F8, actually I am using the interrupt 01h. I am executing interrupt 01h. Yes, whenever you press F8, your processor will come to know, or your processor will be interrupted by the software interrupt, that is int 01h. And what is the function of int 01h? That is single step operation. तो सिंगल स्टेप ऑपरेशन जो करना है वो ISR में छोटा प्रोग्राम होता है, ISR में, ताकि प्रोसेसर को अभी पता चलता है कि इट विल जंप फ्रॉम द मेन प्रोग्राम, इट विल गो टू द ISR. In that ISR there is a small program written, to which is reserved for execution of single step operation, to execute the single step operation. Okay, तो इसलिए याद रखना, whenever you are pressing F8, you are interrupting the processor, you are interrupting the normal operation of the processor, you are interrupting into the main program of the processor. Okay, and every time when you press F8, you are interrupting by using the software interrupt int 01h. I hope you understand this.
सर सर बट int 01h तो हम लोगों के कोड में नहीं लिखा है, तो सर ये हार्डवेयर इंटरप्ट नहीं होगा क्या, बिकॉज हम कीबोर्ड से इंटरप्ट दे रहे हैं सर. तो
even though we are giving, see, this can be understood by two different ways, where even though you are giving, you are pressing the F8 key, okay, yes, even though it is a hardware interrupt, but this hardware interrupt, when you are pressing F8, जो F8 का काम होता है, that is a single step operation. The same thing is happening in the software interrupt, that is 01h. So I need to make you understand that pressing F8 is actually nothing but single step operation. And similarly, we have the software interrupt, that is int 01h, which both are of them are same. And if you ask me, sir, pressing F8 is hardware, yes, it is hardware, because we are externally we are interrupting the normal flow of the program. Okay, but this pressing of the hardware F8 is nothing but converting that hardware interrupt into the software interrupt, that is int 01h. Okay, so that thing you can correlate. But if in the program I am writing down 01h, program में ही मैं लिख रहा हूँ 01h, then it is nothing but single step operation. It is nothing but a single step operation. तो हर एक इंस्ट्रक्शन के बाद 01h लिखो, हर इंस्ट्रक्शन के बाद 01h लिखो, लास्ट में फिर F9 प्रेस करके फुल एग्जीक्यूशन करो, बट दैट विल एग्जीक्यूट वन आफ्टर द अदर. एक इंस्ट्रक्शन एग्जीक्यूट हो जाएगा, ओके, तो बताएगा कि बिकॉज ऑफ सो इंस्ट्रक्शन व्हाट इज हैपनिंग, then you have int 01h, that is a single step operation. So what I mean to say that we will be not writing that 01h all the time after every instruction. but I can correlate that pressing F8 is nothing but single step operation, which you can try to correlate with the software. Okay, so purely speaking, pressing F8 is a hardware interrupt. Yes, you are right, but internally that is a software interrupt 01H. लेकिन हम हर इंस्ट्रक्शन के बाद 01H नहीं लिख सकते. So that's why I try to explain you with relation with pressing F8. Is it clear?
Yes sir.
मतलब अगर किसी लाइन के बाद हमने 01H लिखा है तो फिर वो लाइन स्किप कर देगा क्या?
नहीं, वो क्या करेगा फिर, वो आप 01H लिखने के पहले जो आपने एग्जीक्यूट किया है, ओके, वो एग्जीक्यूट हो जाएगा, फिर वो रुकेगा, and then it might give you the message that press any key to continue. Then you can press, then the next instruction after int 01H will be executed. और वो इंस्ट्रक्शन के बाद फिर से अगर अपन ने int 01H लिखा है, then again it will stop, because you are executing the instructions one by one. So it is a single step, because all the instructions won't be happening in a single go. Okay, it will happen step by step. It will happen step by step. So every time you have to halt, and every time you have to press any key to continue. That is the mean. Is it fine?
Okay sir.
You can try with this int 01H. Okay, you can try. You write down this int 01H after a few instructions. Okay, and then you can see कि actually क्या मैसेज आता है स्क्रीन पे. Okay, जो भी मैसेज आता है, जो भी कुछ चेंजेस होता है, वो होता है because of the small program of ISR. Because of the small program of the ISR. Always remember this. जो भी आपको स्क्रीन पे दिखता है, ये होने के बाद वो होने के बाद, दिस इज ऑल हैपनिंग बिकॉज ऑफ द इंटरप्ट, एंड एवरी डेडिकेटेड इंटरप्ट वी हैव. ये ऐसा होगा तो ऐसा होगा, ऐसा होगा तो वैसा होगा. So this is all happening because of the small program stored in the ISR. Always remember this. So that's why we have total 256 interrupts. Okay, 256 to handle different types of situations. Okay, so out of that we have studied 2. Go to the next one. Number 3, int 02H. int 02H. This is reserved for non-maskable. ब्रैकेट में लिखो NMI पिन. NMI पिन. अभी मैं can I comment now that whenever you are interfacing any external device to NMI pin, and whenever that particular device wants to interrupt the processor, can I say it is interrupting through the software interrupt of int 02H? Can I say this?
Yes sir.
Yes. So whenever you have any device connected to NMI pin, actually you are using the software interrupt. The dedicated software interrupt is int 02H. Okay, int 02H. तो हमेशा याद रखना, NMI पिन पे जो भी डिवाइस कनेक्टेड रहेगा और अगर उसने इंटरप्ट करने की कोशिश की तो आपका सॉफ्टवेयर इंटरप्ट एक्टिव होता है, दैट इज 02H, और वो फिर मेन प्रोग्राम से जाता है छोटा प्रोग्राम ISR, और फिर उस पे जाने के बाद वहां पे जो भी कुछ लिखा है, सपोज वो प्रोग्राम में ऐसा लिखा है कि प्रोसेसर को बताने के लिए कि देयर इज सम हार्डवेयर इंटरप्ट, देयर इज सम हार्डवेयर डिवाइस वांट्स टू इंटरप्ट यू, बट एक्चुअली देखा जाए तो NMI दिस इज नॉन मास्केबल. इसमें रिक्वेस्ट नहीं होता है, प्रोसेसर को अपना सब काम छोड़ के उसको सर्विस देना पड़ता है, बिकॉज इट इज नॉन मास्केबल. ओके, सो शायद इंटरनली ऑपरेशन ऐसा होता है कि प्रोसेसर को पता चलता है कि यस देयर इज अ नॉन मास्केबल इंटरप्ट, सो it will leave all its work and it will give the service to that particular device which is connected to NMI pin. Is it clear to everyone?
Yes sir. एक डाउट है.
हाँ
सर, हार्डवेयर इंटरप्ट्स के लिए मतलब कोई इंस्ट्रक्शन सेट नहीं होता क्या? तो सर फिर वो मतलब पता कैसे चल जाए प्रोसेसर को?
वो जो आपने इंस्ट्रक्शन सेट की बात की है ना, वही ISR में होता है. वही जो इंस्ट्रक्शन सेट की बात कर रहे हो वही ISR में प्रेजेंट होता है. तो ISR बोले तो व्हाट इज ISR? दीस आर द स्मॉल ग्रुप ऑफ प्रोग्राम्स टू हैंडल सम स्पेसिफिक सिचुएशंस. जैसे ये सिचुएशन आया है, NMI पिन पे हार्डवेयर डिवाइस को लगाया और उसको इंटरप्ट करना है, उसको कुछ प्रोसेसर को इंटरप्ट करना है एंड टू कैरी आउट इट सम वर्क. ओके, तो processor will go from its main task, will go to the ISR. और ISR में प्रेजेंट वही होता है कि एक्चुअली कौन सा क्या प्रोग्राम एग्जीक्यूट करना है. ओके, so ISR will have some instructions which will do the some specific task, and we do not have the right to change this particular program. So always all of you remember ISR में कुछ भी हम change नहीं कर सकते because they are reserved. Okay, we as a programmer do not have the access, or we do not have the rights to change the content of the ISR. That is predefined. INT 00 आया, INT 00 आया, ये करना है, ISR में मेंशन है. INT 01 आया, ये करना है, ISR में प्रेजेंट है. INT 02 आया, ये करना है, ISR में प्रेजेंट. So that is the main. हाँ बोलो
सर. लेकिन ISR में जंप करने के लिए भी हमको सॉफ्टवेयर इंटरप्ट का ही मतलब उसके यूज से ही हम उसमें जा सकते हैं ना?
हाँ ना, बराबर है ना, सॉफ्टवेयर के थ्रू ही आपको जाना पड़ता है ना ISR में.
हाँ सर, मतलब लेकिन अगर कोई हार्डवेयर पेरिफेरल डिवाइस जो इंटरप्ट दे रहा है सर, वो कैसे मतलब कंपाइलर रिकॉग्नाइज करेगा कि और वो सब रूटीन कैसे शिफ्ट होगा? मतलब अगर सर उसके लिए कोई स्पेसिफिक सॉफ्टवेयर इंटरप्ट नहीं होगा अगर
तो
सर, तो
यही तो है ना INT 2 ही है ना. फिर आपने एनएमआई पिन पे हार्डवेयर डिवाइस पेरिफेरल डिवाइस लगा दिया, तो INT 2 तो केयर कर रहा है ना. फिर आपका INT 2 ही तो बताएगा प्रोसेसर को कि आपको ISR में जंप करना है.
ओके सर, समझा.
बराबर है ना.
हाँ सर.
हाँ, so there is a NMI pin available to do the task of moving from main program to the ISR by INT 02H. Is it clear?
Yes,
write down the fourth one now. INT 03H. INT 03H. Have we used this INT 03H?
Yes sir, हम लोग तो इसको प्रोग्राम में यूज करते हैं.
Yes. What is the purpose of using INT 03H? Setting a
Sir, initial value.
No, it is setting a breakpoint. आप जब F9 दबाते हो, आपका पूरा प्रोग्राम एग्जीक्यूट होता है और जाके कहाँ पे रुकता है? INT 03 पे, because we have given a breakpoint there. Yes or no? So why? So please see in your program where you have mentioned INT 03H. It will be somewhere down, third last line or second last line. Not second last, but 03 कहीं तो भी mentioned रहेगा. So that is reserved, or it is used to setting a breakpoint. So please write down INT 03H is reserved for setting a breakpoint. तो मेरा एग्जीक्यूट करो और बस वहां पे जाके रुको. Your code segment contains lots of program. लेकिन suppose मेरा aim है addition of 2 numbers, और मेरा addition of 2 numbers suppose consists of only 5 lines. तो मेरा सिर्फ कोड सेगमेंट में मैंने जो 5 लाइंस लिखे, मुझे वो सिर्फ 5 लाइंस एग्जीक्यूट करना है, ना कि मुझे पूरा कोड सेगमेंट में जो लिखा है वो पूरा एग्जीक्यूट करना है. तो मैं क्या करूंगा, आई विल स्टार्ट फ्रॉम 1 2 3 4 एंड 5 एंड लास्ट में मैं लिखूंगा INT 03H, ताकि वो पूरा एग्जीक्यूशन ना करे, ये ऊपर के 5 लाइंस एग्जीक्यूट करे और बाद में ब्रेक पॉइंट देने के बाद जब मैं ब्रेक पॉइंट दूंगा INT 03H यूज करके, तो वहां पे रुक. Is it clear?
Yes sir.
So this is INT 03H setting a breakpoint. Okay. The next, number 5, INT 04H. INT 04H. Now this is reserved for overflow. During some operations, it might happen there is an overflow. You understand the meaning of overflow. So after overflow, there might be some message which might pop up on your screen, which will give you the message that there is an overflow. So how do you get this message of overflow? only because of this interrupt, that is int04h. Okay, so this is internally happening. This is a software interrupt. कहीं पे भी during the operations or during the execution, if it happens that there is an overflow, that overflow is nothing but there is an interrupt of 04, and because of this overflow, the message may pop up on your screen that there is an overflow. Okay, so for overflow, whenever there is an overflow, that means there is an interrupt of 04h. There is an interrupt of 04h. तो कैन आई से जो भी आप लिख रहे हो, द फंक्शंस असाइंड, डिवाइड बाय 0, सिंगल स्टेप, नॉन मास्केबल, break point. So can I say these are the dedicated functions assigned, and for these dedicated functions which are assigned, you have their dedicated interrupt number. You have dedicated their interrupt number. Okay. So interrupt जो interrupts है, sometimes we are using in the instructions जैसे int03. अगर हम use भी नहीं कर रहे हो, but during the execution, suppose divide by 0 हो रहा है, तो there is indirectly you can say there is an interrupt 0h. अगर indirectly कहीं overflow हो रहा है, तो you can say indirectly there is an interrupt of 04h. Okay, so you have to assign, you have to correlate, you have to have the one-to-one matching of int type with the function assigned. So for int00, the function assigned is divided by 0. For int01, the function assigned is single step. For int02, the function assigned is non-maskable. For int03, the function assigned is breakpoint. Okay, and similarly for the that is int04h, the function assigned is overflow. The function assigned is overflow. Okay, and the last one you can write down. I have told you there are 256, but we are not going to understand all. Write down the last one, int05h, and this is reserved for print screen. This is reserved for print screen. Now most of you are using the laptop. Can you identify the key which is used to print screen? Do you have that key on your laptop keyboard?
हाँ सर.
कहाँ पे है मुझे बताओ.
सर नंबर पैड के ऊपर,
सबसे ऊपर वाला रो.
हाँ मतलब सर डिलीट की के बाजू में.
यस अभी मैं मेरा लैपटॉप देख रहा हूँ कीपैड, उसके सबसे ऊपर रो में राइट से फोर्थ की है, उस पे लिखा है PRTSC. आपके प्लीज चेक, जो डेस्कटॉप पीसी भी अगर शायद होगा तो उनके भी कीबोर्ड पे देखो, या फिर लैपटॉप जो यूज कर रहे हैं उनके भी कीबोर्ड पे देखो. यू विल सी PRTSC. So can I say whenever I want to print screen, आप लोगों ने यूज किया है PRTSC? Any one of you?
यस सर.
हाँ सर. हाँ
यस
सर.
सर.
हाँ, तो मुझे एक बात बताओ, अभी मुझे अगर मेरे स्क्रीन पे जो भी है मुझे उसका स्क्रीनशॉट लेना है, तो आई थिंक मोस्टली अलोंग विद द प्रिंट स्क्रीन यू मस्ट हैव यूज्ड द की विंडो की.
Yes,
No,
sir.
sir.
Windows
No,
all
sir,
time print
direct.
screen.
हाँ
Directly.
देखो, हाँ देयर आर मेनी ऑप्शंस अवेलेबल, लेकिन अगर मुझे है ना लेना है ना, अच्छा ऑल ऑफ यू वॉच ऑन द स्क्रीन. आपकी स्क्रीन पे देखो, स्क्रीन पे असेंबलर डायरेक्टिव दिख रहा है.
यस सर.
अभी देखो, अभी जैसे आप जब क्लिक करते हो ना, तो क्लिक करने के बाद अगर आप कैमरा से क्लिक करते हो फोटो, तो फ्लैश होता है, फ्लैश. अभी देखो मैं क्या कर रहा हूँ, विंडो की और प्रिंट स्क्रीन को एट अ टाइम दबा रहा हूँ, तो यू विल सी समथिंग फ्लैश. ओके, जस्ट वॉच ऑन द स्क्रीन ऑल ऑफ यू. एक मिनट, कैन यू सी दिस?
हाँ यस सर.
तो हम कभी भी है ना विंडो और प्रिंट स्क्रीन को अगर एट अ टाइम प्रेस करते हो, तो एक्चुअली यू आर taking the screenshot and that is stored. Can any one of you tell me where it is stored?
सर कैश मेमोरी.
कैश मेमोरी. और मुझे एक बात बताओ, आपके कौन से फोल्डर में जाके वो स्टोर होता है? Okay, I will tell you. It will be stored into your folder. That is, the folder name is pictures. Okay, मैं आपको बताता हूँ. Let me show you this. See, go to this PC. In this PC, Can you see your pictures?
Yes, sir.
Okay. So in these pictures, there is a screenshot. Can you see the screenshots?
Yes, sir.
अभी इसको डबल क्लिक किया मैंने, देखो क्या है अंदर, क्या है देखो, ये देखो मैं अभी उसको क्लिक किया, अंदर देखो क्या है. It will take time. See, can you see this screenshot जो मैंने अभी लिया था assignment directives का?
Yes, sir.
Yes, sir.
So yes, so by default it is stored into the folder. That is a screenshot folder. That is the pictures. In the pictures you will see the screenshot, and in that screenshot you will see whatever the screenshots you have taken, that is stored there. So what I meant to say that whatever, if you are pressing print screen, this is nothing but which is equivalent to the software interrupt INT05H. I hope you have understood this. 05H. Okay. So मैं अगर hard, this is, yes, again right, I am pressing the print screen along with the window key. Okay, that is I am using the hardware interrupt, but that is equivalent to the INT05H. That is equivalent to 05H. अगर हमको हार्डवेयर की यूज नहीं करना है तो इन द प्रोग्राम इटसेल्फ यू कैन राइट डाउन INT05H. तो वो जब वो एग्जीक्यूट होगा INT05H, तो ऑटोमेटिकली दैट स्क्रीन विल बी कैप्चर्ड, प्रिंट स्क्रीन विल बी कैप्चर्ड. Is it okay to everyone? Is it okay to everyone?
Yes, sir. Yes, sir.
Yes,
Yes,
sir.
yes. There should be no doubt now. So please go back to our PPT. Yes. Now this is all about the INT. Questions are asked 0, 1, 2, 3, 4, 5. बस इसके ऊपर नहीं आएगा. But if you want, you just can go to some important one. Okay, मैं सभी नहीं लूंगा. You do this as a homework. Okay, मैं सभी नहीं लूंगा. I can just read out. Print screen है, बाद में 06 है वो रिजर्व्ड है, 07 वो रिजर्व्ड है, 08 वो टाइमर के लिए है, 09 कीबोर्ड के लिए है. ओके, देन हाँ, दिस इज ऑल्सो इम्पोर्टेंट. ये भी मैं आपको बताता हूँ. INT0A से लेके INT0D, so these are hardware interrupts. Okay, 0A से लेके 0D, these are the hardware. So 0A, 0B, 0C, 0D. So there are the 4 INT software interrupts which are hardware interrupts. Okay, and INT0FH which is hardware interrupt. So these are the few. You can go through this. Okay, ये interrupt software interrupt मैंने यहाँ तक लिया है. You can just write down somewhere, note में लिखो. All of you write down in the note. INT21H ये important interrupt है, ये मैं अलग से लूंगा. नोट में लिखो INT21H, INT21H, कॉमा INT21H कॉमा, ये इंपॉर्टेंट है, मैं ये अलग से लेने वाला हूं. और इसी में लिखो INT21H कॉमा 4CH, INT21H कॉमा 4CH. ये भी एक स्पेसिफिक इंटरप्ट है 21H का. ये दो इंपॉर्टेंट है, ये मैं आपको अलग से लूंगा. तो आपने नोट में ये लिखा है. So that is a reminder that we need to study this afterwards. Okay, now come back to the screen. Now we are going to understand the assembler directives. This is also important. Pay attention. Assembler directives. Everyone is able to see my screen?
Yes, sir.
Yes, sir.
Yes. Now we have done with the software interrupt. Now we are moving to the other part, the topic. The other topic is assembler directives. This is also important. Questions are asked on this. Do not try to ignore this topic. This is important one. Okay, and even in the Vivas also the questions are asked. Okay. Now assembler directives are what? What do you mean by assembler directives? So we'll see what do you mean by assembler directives. Pay attention on the screen now. Instructions to the assembler regarding the program being executed. Now, whatever the instructions you are writing down, whatever the program you are writing down, I have told you for every instruction you have opcode. For every instructions you have opcode. Now, assembler directives are also instructions but the only difference between the assembler directives and the instruction, the pure instruction, is that assembler directives will not have the opcode. Assembler directives will not have the opcode, but it will instruct the program. It will give some instruction to the program. Okay, तो आपका पहला सेंटेंस क्या है? Instructions to the assembler regarding the program being executed. Regarding the program being executed. Okay, regarding the program being executed. They are also called as नीचे वाला third वाला. They are also called as pseudo instructions. Can any one of you tell me what is the dictionary meaning of pseudo? Here P is silent. What is the dictionary?
False.
Yes, you are right.
Sir, false.
Yes. Can any one of you, where you have read this pseudo, associated with what?
Pseudo code.
Sir, pseudo.
Yes.
Yes, बताओ.
सर सूडो फोर्स और सूडो कोड.
Pseudo code. आपने स्कूल में भी पढ़ा होगा pseudo.
Sir, pseudo code.
Pseudo code.
सूडो फोर्स.
Okay. Somewhere in the high school also you must have studied in the biology.
Sir, pseudopodia, false feet.
Pseudo?
Pseudopodia, false feet.
False feet. What is the meaning of that?
So amoeba has. pseudopodia.
Yes, you are right. I was searching for this answer only. You are right. So can I say amoeba? Amoeba is having a false leg. They are having a small tiny leg, but they are the false leg. So so in that respective you have studied this pseudo. Okay, the false. So I meant to make you understand that these are the false instructions. Even though it looks like an instruction, it will instruct to the assembler. But nowhere the instruction will be converted into the opcode. It will not have its opcode. और आपको पता है आपका opcode कहाँ पे सेव होता है? कोड सेगमेंट में. So no opcode is reserved in the code segment for the assembler directive. So why it is called as a directive? Only because it is giving direction to the assembler कि ये करना है, वो करना है. लेकिन it is not consuming space. Why it is not consuming space? Because it is not converted into opcode. And if it is not converted into opcode, opcodes are not reserved into the code segment. Is it clear to everyone? This is as simple as it is. Okay, so that is why it is called as a pseudo instruction.
But so,
हाँ
सर अगर वो मशीन कोड में कन्वर्ट नहीं होगा तो सर वो इंस्ट्रक्शन फिर कैसे समझेगा सर मशीन को?
वो मशीन को समझ में आता है. That is why there are some dedicated assembler directives. जैसे DB that is defined by DW, defined word. उसका कुछ ऑपकोड होता है? नहीं होता है. आप टाइजर में प्रोग्राम लिखते हो ना, DB का देखना उसका कुछ ऑपकोड होता है क्या? नहीं होता है. बट दैट आल्सो, लेकिन DB का क्या काम है? DB का काम है कि एक वेरिएबल में एक वेरिएबल है, आप DB के पहले वेरिएबल लिखते हो और DB के बाद आप नंबर लिखते हो एंड आप बताते हो कि वो नंबर है बाइट, 8 बिट्स का नंबर है. अगर वो नंबर है 16 बिट्स का तो आप बताते हो DW. आप डायरेक्शन दे रहे हो ना असेंबलर को कि वो जो नंबर है वो वर्ड है या फिर बाइट है. ओके, सो इट इज जस्ट गिविंग यू द डायरेक्शन टू द असेंबलर. इट इज नॉट कंज्यूमिंग स्पेस, it is not converting into the opcode. Is it clear?
Yes, sir.
Yes. See the second one, control the generation of machine codes and organization of the program, but no machine codes are generated for the assembler directives. जो मैंने अभी बताया, there are no machine codes generated. Okay, so no machine codes are generated. So why it is used? It is used to specify the start and end of a program. Can I say the start and end? आप लिखते हो program. I want everyone to imagine this. Have the visualization of this in front of your eyes. Okay, आप start लिखते हो, आप end करते हो. कहीं वो कुछ कंज्यूम कर रहा है, उसका कुछ ऑपकोड होता है स्टार्ट का और एंड का? नहीं होता है. लेकिन वो क्या बताता है कि विद इन द स्टार्ट एंड एंड यू हैव रिटन सम इंस्ट्रक्शन. ओके, बाद में क्या? अटैच वैल्यूज टू द वेरिएबल्स लाइक DB, DW. So it is attaching the values to the variables. Okay. Allocate storage locations to input and output data. तो इनपुट और आउटपुट डेटा हम जो भी यूज करते हैं उसको एक स्टोरेज स्पेस अवेलेबल करता है, उसके लिए स्पेसिफिक डायरेक्टिव्स है। अभी जो भी मैं डायरेक्टिव्स बताऊंगा उसको मैं इंस्ट्रक्शन नहीं बताऊंगा, ओके, नहीं तो यू विल हैव अ कंफ्यूजन इंस्ट्रक्शन। सो द क्वेश्चन में बी आस्क्ड दैट टेल मी द डिफरेंस बिटवीन इंस्ट्रक्शन एंड द डायरेक्टिव्स, सो आई हैव टोल्ड यू द डिफरेंस, ओके। सो allocate storage locations to input and output data. The fourth one is define start and end of segment. हाँ, अभी यहाँ पे ये लास्ट वाला इंपॉर्टेंट है, डिफाइन स्टार्ट एंड एंड ऑफ सेगमेंट। कैन एनी वन ऑफ यू टेल मी विच इज द डायरेक्टिव विच विल टेल यू द स्टार्ट एंड एंड ऑफ सेगमेंट? Can any one of you tell me which is the directive which will define the start and end of the segment? No one?
सर स्टार्ट कोलन।
No. Start colon तो वो है ना, specify the पहला वाला, specify the start and end of a program. This is simple. Define start and end of a segment. आप लिखते हो ना सबसे स्टार्टिंग में डेटा सेगमेंट, फिर उसके नीचे 2-3 लाइन लिखते हो, बाद में लिखते हो डेटा एंड्स, बाद में आप उसके बाद लिखते हो, बराबर है ना, उसके बाद आप लिखते हो ना कोड सेगमेंट, और कोड सेगमेंट के बाद बहुत कुछ लिखते हो, और सबसे लास्ट में क्या लिखते हो, नॉट सबसे लास्ट, सेकंड लास्ट में क्या लिखते हो, कोड एंड्स।
हाँ सर।
यस, सो कैन आई से डेटा सेगमेंट डेटा एंड्स, कोड सेगमेंट कोड एंड्स? कैन आई से दीज आर द डायरेक्टिव्स?
Yes sir.
Can I? Yes. So these are the directives. These are the directives. Okay. So they will not consume any space. They will not be converted into the machine codes. Okay. They will give just the direction to the assembler. What is written in between them are the instructions, or they are related with the data segment, or they are related with the code segment. Am I right? So they are called as the assembler directives. So I am not going to explain everything. This is in front of you. Please pay attention. DB defined byte. DW. Yes. As far as DB is concerned, these are the things. Okay. I already have shared you the PPT. Please go through this. Okay. So this is not new to you. There is with an example. Okay. Please go through this. Defined byte ho gaya. Defined word. It is also related with the 16-bit. You have examples. Okay. Please go through this. Segment ends. ये देखो, there is an example. Okay, there is an example. Assume, yes, this is also important. Assume हम करते हैं ना, assume CS colon code, comma DS colon data, हम लिखते हैं ना ये code segment के बाद. So this is also the assembler directive. This is also the assembler directive. Okay. ये सब you have to go through this. Okay. See here example. Assume CS A code, DS A data. अभी A data A code मैंने बोला था आप खुद का नाम भी लिखो, मैंने आपको बताया भी था, मैं खुद का नाम भी लिख सकते हो। आपको अगर वो खुद का नाम डेटा सेगमेंट नहीं पसंद तो खुद का नाम दो, बट अज्यूम करना है आपको। अज्यूम में लिखना पड़ेगा कि CS बोले तो आपका नाम है या एक्चुअली क्या दिया है। ऑलरेडी दिस थिंग आई हैव टेकन, सो दिस इज नॉट न्यू टू यू। ओके, देन कम्स this assembly. Yes, org क्या कर रहा है, is used to assign. So I want everyone to go through this. And हाँ, एक मैं ये लास्ट वाला बताता हूँ, equate is used to attach a value to a variable. अब equate जैसे आप db लिखते हो ना, वैसे equ भी लिख सकते हो। equ का मतलब होता है equate. This is nothing but equal to. For example, a equal to b. I can write down a equ equate to, sorry, मैंने क्या बोला था, a equal to 1. Suppose a equal to 1. Okay, I can write down a equ 1, यानी 1 is assigned to a, that is a equals to 1. अगर मैं बोलता हूँ xyz equals to suppose 3, तो मैं पैसा में क्या लिखूंगा xyz equ 3. Okay, तो equate का मतलब होता है it is used to attach a value to a variable. So here variable is xyz and the value is 3, So we'll see this equate in the some other example. Okay, Already see the examples are there. I want everyone to go through these examples. Okay. As far as procedure, do not go with this far and near. Procedure, NP. Procedure, NP is end procedure. See, you can just go through this. Okay. PROC indicates the beginning of a procedure. E and DP, end of procedure, and so on and so forth. You can go through this. If you have questions, you can ask me next time. Okay, these are the examples. Short jump, this is also the one of the thing. Macro and end macro. So there is a, in your syllabus, you do not have the procedure and the macros. Okay, so we will not go through the procedures and the macros, but if you are interested, you can just go through this macro. अगर प्रोसीजर को एंड करना है तो ई एंड डी पी, और मैक्रो को एंड करना है तो ई एंड डी एम. Okay, and there is a difference between the procedure and the macro. I think you must have studied in some other programming also, but if you are interested, you can go through this, but this is not part of your syllabus, so we won't go this. We will not go into the detail of understanding this. Okay, so this is the end about the assembly directives. I have told you the software interrupt. Okay, so if you have any questions, you can ask me next time. This is a homework. Go through all the directives. Okay, macros, procedures, वो भी करना है तो वो भी करो, and if you have doubt, you can ask me next time. Parmeshwari madam, you can take the attendance.
हेलो सर.
सर मैम.
अच्छा, परमेश्वरी मैडम नहीं है क्या?
हाँ, एग्जाम डिपार्टमेंट मध्ये गेलेत मॅम.
ओके, नो प्रॉब्लम. अभी मेरा भी सुपरवाइजर ड्यूटी है 11:10 को, तो मुझे भी निकलना है. मनीष माझा लवकर घेतो का अटेंडन्स?
हाँ घेतो ना. भुवना प्लीज अटेंडन्स दे ना.
ओके. रोल नंबर 1. रोल नंबर 1 absent. 2
present, ma'am.
3
3 present.
4
4 present.